In this question, we have a block of mass m that contains a positive charge q, and the system is placed over the smooth horizontal surface. Now an electric field is switched on and the initial distance between the block and the wall is small d. Now we have to calculate the time period for the resulting oscillatory motion. Now first of all, let's calculate the time required for the block to reach to the wall. So the force that is experienced by the block due to the electric field is given by QE. So acceleration due to this electric field will be given by F electric by mass, that is QE by m. Now we are using the equation S is equals to ut plus half at square. As we have to calculate the time t, we know that u is 0, s is given to me as d, acceleration I calculated equal to qe by m, and let my t is equal to t1, that is the time required for the block to reach to the wall. So d is equal to qe by 2m into t1 square. So t1 comes out to be 2md by qe to the power 1 by 2, and the velocity of the block when it reaches the wall can be calculated by the equation v is equal to u plus at. U is 0 as I told you above. Acceleration is again qe by m into time is 2md into qe to the power 1 by 2. That can be manipulated as, now as the collision is purely elastic, the velocity v with which the block q is colliding with the wall will be the initial velocity when the block will come back to its original position. So the v will change into u2, and to calculate the time t2 we'll be using the equation v is equal to u minus at. Now we are using minus because in this case the block will deaccelerate, because the direction of electric field is opposite to the direction of motion, but the magnitude of acceleration will still be the same. So final velocity will be equal to 0 as the block will stop finally. The value of u is given to me by qe by m into 2md by qe to the power 1 by 2, and let t is equal to t2 that I have to calculate, and acceleration is qe by m. So u is equal to at2, that comes out to be qe by m into 2md by qe power 1 by 2 is equal to qe by m into t2. So this qe by m is cancelled by this, so the value of t2 comes out to be 2md by qe to the power 1 by 2. So the total time of oscillation that I have to calculate is given by t1 plus t2, that comes out to be 2 times of 2md by qe to the power 1 by 2. That's the answer.